integral 0 to 2, 1 over cube root of 2x minus 1 dx. If we look at the interval of integration 0 to 2, then we see when x equals to 1/2, we have infinite discontinuity, so we'll have to break the integral into two pieces, integral 0 to 1/2 and integral from 1/2 to 2. Then copy what you have to copy. Copy again the function which we integrate. So let's concentrate on the first integral. The first integral is integral from 0 to 1/2 dx divided by cube of 2x minus 1. So we have problem at 1/2. So instead of 1/2, we're going to h, we're going to get 0 to h. We say, well, h is eventually going to approach 2, and it's going to approach 2 from the left. So we're going to have 2x minus 1 to negative 1/3 dx. Mentally do use substitution u equals to x minus 1, so 1/2. New power will be 2/3 multiplied by reciprocal. From 0 to h. Don't forget limit as h approaching 1/2 from the left. So we're going to get limit when h approaching 1/2 from the left. 3/4. Substituting 0, we're going to get 2h minus 1 2/3. Minus substituting 0, we're going to get negative 1 2/3. So we're going to get 3/4. When we substitute the limit value for h, which is 1/2 from the left, we're going to get 2 times 1/2 minus 1, which is 0. 0 minus 1, so we're going to get negative 3/4. So we get negative 3/4 for the first integral. Now we're going to calculate the second one. So calculate the second integral. Second will be from 1/2 to 2 dx divided by cubic root of 2x minus 1. So before we have problem spot that x equals to 1/2, so put h instead of it. We're going to take limit when h is eventually going to be at 1/2. We're approaching at 1/2 from right. Similar antiderivative as we did before, so limit as h approaching 1/2 from right. Antiderivative will be 3/4. 2x minus 1 to 2/3. Limit as h approaching 1/2 from right. So we're going to get 3/4. When substituting 2, we're going to get 3 to 2/3 minus 2h minus 1 to 2/3. Now we substitute in h equals to 1/2 from right, so we're going to get 3/4. Cubic root of 9 minus h equals to 1/2 at the limit value, so 2 times 1/2 is 1, 1 minus 1 is 0. So we're going to get 3/4 cubic root of 9. That will be the second guy. You remember the first guy was equal to negative 1/4. So the integral from 0 to 2 dx divided by cubic root of 2x minus 1 is going to be equals to negative 3/4 plus 3/4 cubic root of 9. If you like, factor 3/4 out, write down positive number first, then subtract negative number. That's the final answer for this problem. In our example, if we do integral dx divided by x cubed, we're doing it from 1 to plus infinity. We're going to have a trouble spot plus infinity. So instead of trouble spot, we're going to put h. Then we'll say, well, h is approaching plus infinity. So antiderivative is going to be x to the negative 3. So we're going to get x to the negative 2 divided by negative 2. So negative 1 over 2x squared, 1 to h. The limit is h approaching plus infinity. So substituting h, we're going to get negative 1 over 2h squared. Substituting 1, we're going to get plus 1 over 2. Limit is h approaching plus infinity. We're going to get negative 1 over 2 times plus infinity squared. That's what h is. Plus 1/2. Notice that plus infinity squared is infinity. Infinity times 2 is infinity. So what we have here is we take 1 and divide by humongous number. So eventually it's going to be 0. So that expression right here is going to be 0. So we're going to get 0 plus 1/2. So final answer is 1/2 for this problem. For example, integral 0 to plus infinity dx divided by 1 plus x squared, as we did before. Instead of plus infinity, we're going to write h, and then we say, well, h is approaching plus infinity. A derivative of 1 over 1 plus x squared is arctangent. The limit is h approaching plus infinity, and it's from 0 to h. So we're going to get arctangent of h minus arctangent of 0. Limit is h approaching plus infinity. So we're going to get arctangent of plus infinity. Arctangent of 0 is 0. And you recall that arctangent of plus infinity is pi over 2. So answer here is pi over 2. Next example, we have integral from negative infinity to plus infinity x e to x squared dx. So we have here two trouble spots, negative infinity and positive infinity. So we're going to break that into two integrals from negative infinity to something to plus infinity. And that something is going to be a number between negative infinity and plus infinity, and usually we choose 0 for that number. Copy the function to integrate. Then we're going to pay attention on each of these integrals separately. So let's do integral negative infinity to 0 x e to x squared dx. So instead of negative infinity, we're going to write down h. And then we'll say, well, h is approaching negative infinity. Antiderivative x times e to x squared is e to x squared over 2. Do you use substitution u equals x squared? We do it from h to 0. Limit as h approaching negative infinity. So we're going to e to the 0 is 1, so 1/2 minus e to the h squared over 2. So we're going to get 1/2 minus e to negative infinity squared over 2. Negative infinity squared is going to be positive infinity. E to a positive infinity is infinity. So that expression here is going to be the same as e to a positive infinity divided by 2, which is positive infinity. So 1/2 minus infinity is going to be a negative infinity. So that is going to be answer for first integral for this integral. So that is going to be negative infinity. Our first integral is going to be negative infinity. So now let's calculate the second integral. Second integral is going to be similar, 0 to plus infinity, x e to x squared dx. So we have trouble spot plus infinity. We're going to put h instead of it. And we say, well, h is approaching plus infinity. X e to x squared dx. Same as antiderivative as we did before. E to x squared over 2. Now it's from 0 to h. Like in upper bound, we're going to get e to h squared over 2. Like in lower bound, we're going to get 1/2. We have limit as h approaching plus infinity. So we're going to get e to plus infinity squared over 2 minus 1/2. So we're going to get e to plus infinity is e to plus infinity squared is going to be e to plus infinity divided by 2. It's going to be infinity. Infinity minus 1/2 is infinity. So what we got is value of a second integral, which is right here, is positive infinity. So we got our final answer, integral from negative infinity plus infinity x e to x squared dx equals integral from negative infinity to 0x e to x squared dx plus integral 0 to plus infinity x e to x squared dx. Recall that the first integral is negative infinity, second equals to plus infinity. So at the end, we don't know what's the answer. So it's the whole thing is the whole integral does not exist because negative infinity plus infinity is undefined. So the answer is does not exist, period.